back, students. So today we are going to solve a new paper from 062022. This is from October-November series of 2022. You can see that you are allowed for 45 minutes to solve and to make it clear. Okay, so this is paper 2 for multiple choice and is from extended version. Now straightforward going to solve first of the question. You can see that the rate of diffusion of three gases, ammonia, carbon dioxide and methane, is measured. What is the order of the rate of diffusion of the gases from the slowest to fastest? So here the main sequence or the main concept is the MR. You know that the rate of diffusion is directly proportional to the molecular mass MR. If the MR is greater, okay, so then the rate of diffusion, inversely relation. So if the mass is more, then the rate of diffusion will be less. If the mass is less, then the rate of diffusion will be more. So we simply can say that the rate of diffusion is inversely related to the molecular mass. Understood? Now work out for the mass of ammonia, which is 17. Mass of carbon dioxide, it is 44. Mass of methane, it is 16. So I can easily say that the fastest will be methane. Fastest will be methane. Then after that, the slowest will be, the next fastest will be ammonia. And then at the end, carbon dioxide. Understood? So keeping this, now look forward for the instruction. The instruction, we have to find the sequence from slowest to fastest. So we have to write down in the opposite way. This will be the slowest. This will be the fastest. As he is demanding from slowest to fastest, so what should be the answer? The answer is this one. This A, carbon dioxide, ammonia and methane. So A will be the right answer. A will be the right answer. Okay. Okay, so this question 2, in this question it says which description of Brownian motion is correct. So we can easily say this is according to the definition. This is done by the bombardment of smaller particles present in the air. So B will be the correct or better. Now in third question it says the chromatogram obtained using 4 substances J, K, L and M is shown. We have a chromatogram, all the particles, all the samples are placed on the baseline, so you can see easily, and these are the separation. Before going into the samples, I can just quickly analyze and I can say J is the pure particle. Why? Because it is splitting into only one. K is also a pure particle which is only splitting into one. L is also, because it is also splitting into one, but M is the mixture because it is splitting into 3 particles, mean it is made up of 3 different substances. So in this situation, M is mixture, L, K and J are all pure substances. So now we are going for the question. The question is, which statement about M is correct? So in option A it says it is a mixture of J, K only. So remember, M is a mixture, yes. So he says that M is mixture, yes, M is mixture, one thing is correct. But you can see exactly J is present and matching with this M. So mean we can say J is present in M. Next, about K is totally matched, so we can say yes. So J and K both are present in M. So that's why we can say A is correct. It is a mixture of J and K only. For this only, this makes this doubtful and unclear. So that's why we are not going to choose. This is not the mixture of only J and K. There is one more substance which is L. Okay. So now checking for the other options. It says that it is pure substance. No, it's wrong again. It is a mixture of J, K and L. Yes, it is correct. It is correct. So we are going to choose this. Why it is not correct? He says it is a mixture of J, K and an unknown substance, because we can see from this diagram, oh yes, this is not correct. From this diagram we can see L is not present in the M. Okay, so we can say this is an unknown mixture. This is what? This is an unknown mixture. So D is the correct description. D is the correct description. This is the fourth question of the same paper. Yes, here. He says which statement about isotopes of the same element are correct. So first of all, we have to look forward for these statements, whichever is correct, then we have to check these options. In first, he says they are atoms which have the same chemical properties. Yes, till this part it is correct, because they have same number of electron in their outer shell. Yes, so agree that statement 1 is totally correct. Statement 2, they are atoms which have same number of electrons and neutrons. No, till electron it is correct, but the neutrons must be different. For isotopes, neutron must be different. So this statement is not correct. So in any option where 2 is present will not be the correct one. So A is not correct, C is not correct. Now we have to look forward for the third option. They are atoms which have the same number of electrons and protons but different number of neutrons. Yes, this is the definition of isotope, so this is correct as well. So we will go for option B. Okay, so we can say option B is the correct one. Now proceeding for the next question. In fifth question, he says which statement about solid magnesium oxide is correct. So as we don't know what examiner is trying to ask, so we have to read all the statement carefully. He says it is a giant structure. So till this part it is correct, because this is an ionic compound and all ionic compounds have giant ionic lattice or giant ionic structure made up of magnesium and oxygen atoms. Till this part it's then wrong, because magnesium oxide is an ionic compound and they are made up of oppositely charged ions, not of the atoms. So statement 1 is incorrect. B, it is an electrical conductor with mobile magnesium ions and oxygen ions. Yes, okay, so this is, but as the state is not clear, the state is over here. Which statement about solid magnesium? In solid state, the ions are not free to move. That is why statement B is also incorrect. Then in C, magnesium loses electrons and these electrons move freely through a lattice. No, because these electrons are transferred to the oxygen and oxygen turns into oxide ion. So this is again incorrect. So D option, oxygen ions and magnesium ions are attracted to each other in giant lattice. Yes, this is the definition of an ionic compound, that oppositely charged ions are attracted by each other. Understood? So D will be the right one. Then for question 6. In question 6 he says which molecule contains only 3 shared pair of electrons? Only. So we have to focus on this only 3. In this methanol, what is the structure of? We have 3 hydrogen atoms that are bonded directly with the carbon. So 3 pairs are over here. But there are some extra pairs as well. One is for oxygen and the other one is for hydrogen. So there is no only 3 pairs. There are how many pairs? There are 5 pairs of electrons. In Cl2, which is bonded, one Cl is bonded with another Cl, diatomic molecule, only 1 pair. In water, there is 2 bond pairs. And in nitrogen, there is a triple bond. How many pairs are there then? 3. Okay. So that's why we can say, question says which molecule contains only 3 shared pair of electron. So D will be the correct answer, because there are 3 shared pair of electrons.
Sorry, how can we understand that nitrogen has 3 bonds?
Remember that nitrogen has the proton number 7. So in the first shell it has 2 electrons, in the last shell it has how many? 5. To make its outer shell complete, it requires 3 electrons, and as we can see, the formula of nitrogen is N2, mean one of the nitrogen is bonded with another nitrogen. So as I clearly mentioned, and this is the rule, how many electrons are needed to complete the valence shell, that much number of electrons will be shared. So how much? 3. So that's why each nitrogen is going to share 3 of electrons. 3 of electrons. So what we can say, 1, 2, 3. For mutual sharing, each will share again 1 electron. That makes 3 pair of electron, and there we left only what? 1 pair here and 1 pair here. So the outer shell are also complete, and you can see easily that how many shared pair of electrons are there? 3. So question 6 is over here. Now question 7 says, which particles are present in the structure of metals? Remember quickly, what are metals? Metals are in which the positively charged ions are surrounded by the sea of delocalized electrons. So in the metallic structure, there are positive ions? Yes. There are negative ions? No. Okay. There are what? As I clearly mentioned, positively charged ions surrounded by sea of electrons. So no shared electrons, because this is not a covalent molecule, only mobile electrons. So statement 1 or this part 1 and 4 are correct, not all. Okay. So where is 1 and 4? B. Yes.
If this question contains negative particles, would it be counted?
No, these negative particles are actually electrons. These negative particles are not ions. That's why this statement is correct. Okay. Yes, there are negative ions. You see, in metals, what we have a positive charge, ions or cations, and what we have in between these layer of positive charge ion, there are what? Electrons. You can see easily. Yes. So they are negative, but they are not ions. They are negative, but they are not ions. So only positive charge ions, we can label it. These are what? These are ions, positive charge ions, and this one and this one. These are what? The free or mobile electrons. Understood? So only these 2 particles are there, not all. Is it clear? Now question 8. In question 8 it says caffeine. So no need to confuse with this structure. Just focus what is the demand. Okay, the demand is which formula represents caffeine. So whenever this is from organic part, whenever we have this type of the formula, we just have to convert it into molecular form by counting each different type and make it a total of that. How many different atoms? Just write them. We have carbon, we have hydrogen, we have oxygen, and we have nitrogen. These are the different atoms which are present in caffeine. Now just focus fully for carbon initially. So how many carbons are there? 1, 2, 3, 4, 5, 6, 7, 8. So how many carbon atoms are there? 8. So when we say that there are 8 carbon atoms, so option A is totally incorrect because it contains 7 carbon atoms. Now focus for hydrogen. How many hydrogens are there? 3, 1, how much? 4, plus 3, 7, plus 3, 10. How many hydrogens are now there? 10. Okay, so we can say 10 hydrogen atoms are there. Then C8 and H11, so definitely. So now we have a choice for B and C. So we have to count for oxygen atoms. How many oxygens are there? 1 and 2 only. Okay, so there are how many oxygen atoms? Only 2. So both, again we still have a choice. So 2 oxygen atoms. How many nitrogen atoms are there? 1, 2, 3, 4. So how many nitrogen atoms are there? 4. So what we can say, C is the right answer. C is the right answer. Is it clear? Question number 9. Which sample does not contain a number of atoms equal to Avogadro's constant? Remember that. What is Avogadro constant? Avogadro constant is 6.02 times 10 raised to the power 23. 6.02 times 10 raised to the power 23. One more thing, 1 mole of anything always contains Avogadro's number of the particles, 6.02 times 10 raised to the power 23. Is it clear? Now he says that which sample does not, so not is bold, that's why we have to focus on this as well. So okay, so which sample does not contain a number of atoms equal to Avogadro's constant? Remember nitrogen. So what we are going to do? We have to find out the moles. We are going to find out moles of this. 14 gram means 14 divided by the molecular mass of nitrogen, which is 28. So the answer is 0.5. So this is the correct answer, because there is no 1 mole mean. Again, sorry, one more thing, it says the atoms. And remember, this is diatomic molecule. One of the molecule contains how many atoms? 2. So half mole of nitrogen contains 2 atoms of nitrogen. So yes, we can say this contains same moles. So this is not correct. 6 grams of water. So we have to convert them into moles. 6 divided by 18. What is the answer? 6 divided by 18. So the answer is, let me calculate, 6 divided by 18, 0.33. 0.33. But how many atoms are there in 1 molecule of water? 3. 1 oxygen atom, 2 hydrogen atoms. So there are 3 atoms. So we have to multiply this mole by 3. So multiply by 3. So answer is 1 again. So yes, mean yes, it contains not. So we have to choose it as incorrect as well. 4 gram of helium. Again, helium is a monoatomic. We have to find the moles by 4 divided by 4. 4 is the given mass, 4 is the molecular mass or atomic mass. Again, the answer is 1. So again, we can't choose this. So ultimately, the answer should be this one. So let me calculate. 28 divided by the molar mass of carbon monoxide is also 28. So the answer is again 1. But remember, in 1 mole of carbon monoxide, there are 2 moles of atoms, because 1 carbon and 1 oxygen. So we have to multiply the answer with 2. So now the answer becomes 2. So this shows that there are number of atoms, but they are not equal to Avogadro's constant. That is why the answer is D. You got that? Understood? If you can't, I can explain it again.
I thought, why B and C are not correct?
Because they all contains 1 mole of atoms. As I said, you can see how much moles of nitrogen, which is a diatomic there, 0.5. Then we have to multiply it by 2. Why? Because in 1 mole of nitrogen, there are 2 nitrogen atoms because of the diatomic molecule. The diatomic molecule nitrogen contains 2 atoms of nitrogen. So we have to multiply it by 2. So this will give us 1. Understood? So you can see all these contains 1, 1 and 1. But this one contains 2. So that is why D is the not containing Avogadro's number of particles, more than Avogadro's number of particles, or double of the Avogadro's number of particles. Understood? Okay. Question 10. Look like from electrochemistry, okay, from electrolysis. He says that electrolysis of concentrated aqueous sodium chloride. Remember, the short form of concentrated aqueous sodium chloride is brine. Is what? If in some of the question examiner use this word, no need to confuse. Brine is actually concentrated aqueous sodium chloride and molten sodium chloride. So see here, we have sodium chloride, but it's concentrated. So how many ions or what type of the ions are there? Sodium ion, chloride ion, hydrogen ion and hydroxide ion. But in here, because of the molten situation, we contains only sodium ion and chloride ion. Okay, no other ions are there. We know that from our knowledge that the cations will move towards the negative electrode and deposit it. So these will deposit it over here, and the chlorine, because of the negative ion, deposited towards the anode, which is a positive charge electrode, so giving us chlorine. So we can say chlorine will be produced at positive electrode, sodium will produce at the negative electrode. But in this case, we know that there is a competition between the ions. There is a competition between the ions. Now you see here sodium, the concentration of the chloride ion is higher, so these chloride ion will move towards the anode and deposit it, and so we get chlorine gas at anode. But instead of the sodium, hydrogen ion has greater reduction potential, so they will reduce here and giving us hydrogen gas at cathode. Understood? So now see for the question. Keeping all this information, we can say at electrode B, at electrode electrode 1 hydrogen is produced, and electrode 2 chlorine is produced. So hydrogen at electrode 1 and chlorine is at electrode 2. So